Hello everyone, this is Aida Gholami from Agrimet Research Company, and in today's video I'm going to talk about forecast formula in Excel and how to use it and what are these forecast this is a group in Excel, the related formulas and so on and so forth. So let's start. Here, as you can see, I have two columns of data. The first one is days and the second one is canopy cover. CC is standing for canopy cover, which is presented in percent. And this is of course the days. So these are the outputs of a model named AquaCrop. We're not talking about it here. What we're talking about is that you can see there is a growing percent of canopy cover in here. Okay, so it's just going up and upper, and then you can see that as these days are going up, this is also growing. So what we're going to do here is that we're gonna use a forecast formula instead of this data in order to guess what is the number for, let's say, day 71. So I'm going to insert two rows in here so we have a distance between this data, and then what I'm gonna go to do is to put a 71 number, and then I'm gonna highlight it so that we can understand what we are interested in, and then we're gonna guess the canopy cover for this day based on forecast formula and not using this actually model data, and then we can compare them with each other. Okay, so let's start. If you put an equal mark and then type 4 in Excel, you can see this group of functions appearing: Forecast.ETS, Forecast.ETS.confint, Forecast.ETS seasonality, Forecast.ETS stat, Forecast linear, and then the forecast alone. So this forecast is just for compatibility means, and Excel recommends you to not use it. So we're gonna start with Forecast.ETS. I double click on that and the formula is selected for me. It first wants the target date. So the target date is of course the date that you want to predict the data for it. So this is 71 in here. So that's my target date. I put a comma and then it asks for values. So these values are actually those historical values which you're going to present it to the function so that it can develop a formula on it, and then it can find the data for the desired day. By the way, I forgot to say, Forecast.ETS is using an exponential algorithm, an exponential formula to predict this value for you. Okay, so that's based on an exponential method, and then the values are those historical values, but we have two type of values here. So this days are of course the independent values or the x's, and the canopy cover is the dependent values or y's. Okay, so by values in here it means those dependent values. I'm gonna get those values from 8 because I don't want to have the 0. Okay, so maybe I can have 1 0, but these are repetitive zeros, are not what I want to have here. Then I put a comma and then I go for timeline. So this timeline is of course the days, okay, or the independent data. Then you can see there's seasonality, data completion, and aggregation. So those are optional. As you can see, they are coming in a crochet, if I'm pronouncing it right. And those are optional data which you don't have to provide them in order to make this function work. but I will explain them further in this video so that you can understand what are them. So now I close the parentheses to see how is this function actually here working. I press enter and you can see that it has predicted a number for me, which is 14.43. So as you can see here, actually my modeled number here is so similar to it. It can show that how is this function working. Actually is like pretty good in this case, of course. And then so that's it. But here, if you have considered, we had seasonality, data completion, and aggregation. Starting by seasonality, this is actually the pattern that Excel can understand in your data. So if, for example, your data is something like this, let's go in here and type seasonality to explain it more. So let's say I have data like this. So I have 1, 2, let's say 15, and then I go for 2, 4, 6, 8 and 10, and then I go for 3 and 5 and 7, 9 and 11, and then I go for 4, 6, 8, 10, 13. Okay, so let's say these are my data, and for this data seasonality is 5 because it starts from 1 to 5, and you can see a growth in these data, and then it suddenly comes down from 6 to 10. It again goes up, and then it suddenly comes down, and from 11 to 15 it goes up again. But there is a function related to seasonality, and that's Forecast.ETS seasonality, and it returns the length of the repetitive pattern Microsoft Excel detects for the specified time series. So I double click on that. It wants me the values and then the timeline, and that's it. I close the parentheses, and that's 5 as we could actually detect it by ourselves. But in these functions for seasonality, you can just mention 0 or 1. By mentioning 0, it actually doesn't count the seasonality in, and if you input 1, it goes to detect the seasonality. Then for data completion, it's actually used when you have missing data, and you can use this option to autocomplete your missing data by actually averaging the neighbors numbers, and that's what Excel does it for you. And then aggregation is used when you have similar data. So by using functions like COUNTIF, MAXIF, and these other things, I was reading in the manual, it can understand actually what should it do if it faces the similar value. So that's it. It was just a quick explanation for this optional data in here. The next one is in this list is Forecast.ETS.confint. You can see this is the function, and it returns a confidence interval for the forecast value at the specified target date. So let's go for this one. So this was Forecast.ETS and then we bold that, and also I want to move it to here so that it becomes more like organized. And then I want to merge them, and then here I go for Forecast.ETS.confint, if I'm not wrong, actually. Okay, so let's call this function. It wants target date, values, timeline, and then the optionals are confidence level, seasonality, data completion, and aggregation. But what this function does is that it gives you the interval of confidence level. So it shows you a radius that you're okay, so in parentheses I should mention that this function should be used in conjunction with Forecast.ETS with this function. Okay, so it gives you a radius that this output is actually placed in that radius. I will show you what I mean exactly by an example right now. So the target date is here, the values are of course these ones, and the timeline is this one. I close the parentheses and I press enter. So here this is the radius, so 4.2 more than this is actually the upper level of confidence level, and 4.2 minus this number is the lower confidence level. So this number actually gets placed in these two levels. I will show you a very clarifying example by going to go. So let's see, how should we do that? I want to have 72 and 73, and also let's do it for 5 numbers, 73, 74, 75, and 76. Okay, so yeah, that's my data. And then what I want to do is to use this formula for actually, let's say this is going to be relative, so I wanted to move as I go down. Then I want these numbers to be fixed, so this is my fixed, let's say, observed data, and also these ones should be also fixed. And then if you're confused, you can see what I'm going to get. So then I just copied this formula down so that it counts these other numbers that I want in the calculations. So this is for day 71, this is for day 72, this is for 73, and this is for 74, and then I want for 75 and 76. So you can see it goes down. What I want to do is to copy these numbers in here. So I'm sorry, I should paste them by the values. Then I go for the writing the forecasted by Forecast.ETS. Okay, so these are my numbers, and then this is the confidence interval. So I want them also to be calculated for these all numbers. So I'm gonna fix them. I'm sorry, as I'm filming I cannot use F5 so that it just fixes them automatically for me. I go for copying them to this point, I guess. Yeah, that's right. So these are my forecasted values. These are my forecasted ETS confidence interval. So what I'm gonna do is to have a lowest confidence level, and then I go for upper confidence level. This is lower. I'm sorry. So what I want to do is to get this number and then minus this number, and then copy them to all the data. It should be relative so that when I go down, it goes down also. Okay, so I move and these cells also move. For upper confidence level, I go for getting this number and I want to sum it with this number. So I actually used a minus for lower and used a plus for upper, and then I copy all of them also. And what I'm gonna do is to draw a chart for you so that you can understand them better. So those were for the dates 71 to 6, and then I want to have a chart for these ones, and these ones first I go for insert, and I'm gonna insert a scatter plot. Let's say, yeah, this is cool. So I want a scatter plot, and then another set that I want to have is, so I'm gonna add data. The series name is lower, and then X values should be these days, and the Y's values should be lower. So that's it. And then I go for add another set of data. I'm sorry, what happened here? Yeah, okay, no problem. Add another set of data, which is upper confidence level. X values are these ones and Y values are these ones. I click OK and go for it. So here you can see these numbers forecasted. Okay, so let's make another change to this chart, and I want them to, yeah, actually I want to change the colors. Yeah, I guess that's cool. And then in here I can have this, and then for here I can have lighter gray. Okay, so you can see that this is actually the forecasted data, and these are the upper and lower confidence level. So that's what I actually meant. The other formula in here is forecast ETS stat. So what it does is that it goes for actually calculating statistical indices for those predicted values. So it goes to actually comparing the forecasted and the measured, and then it calculates a statistical indices for you to see how is it working. These statistic type that you can see here, so values are the historical values as always, timeline is your dates, and a statistic type differs from 1 to 8. And if I go here for you, let's do it again. So I want it from here to here, and then I want the days, and then in here you can see that the statistical type appears. So first one is alpha parameter of ETS algorithm, beta parameter, and goes down to RMSE. So I want, for example, the RMSE, and I double click on that, close the parentheses, and that's the RMSE number for this actually prediction. So that's how it works. So this was statistic. The last but not least is forecast linear. So forecast linear uses a linear formula or linear trend as it's going in here to predict the value for you. So I'm gonna use it again. It wants the x, known y's, and known x's. So x is for me the day 71, let's say, and then the known y's are these ones, the known x's are these ones. So I close the parentheses, and that's the linear guess for this number. But okay, let's make it clear. Linear. But this linear function actually is the one that you can have in your actually graphs. So let's say I want to have this graph for me. I go for insert and insert a graph, and then I go for this plus option in here. I go for trend line. So I click on this option and I go for linear. It's not working. Yeah, here, linear, and then I go for display equation on chart. So this is exactly what Excel goes for when you use forecast linear. So if you calculate the y being 71 and if you calculate y for x being 71, you get the exact same value as this one. So that's it. I guess that's it for today's video. I hope you learned something new. Please don't forget to give this video a thumb up and subscribe to Microsoft channel. I will see you in the next video, and bye.